Good afternoon, everybody, and welcome back to part two of this epic series where we look at the workflow required for designing any connection using robot and IDEA StatiCa. So, if you haven't checked out part one, please do so before proceeding with part two. But if you have, let's go for it. So, without further ado, let's proceed with the modeling, analysis, and design of our part two connection. Alrighty, so we have got our part two connection in front of us, or connection two, and you can see that this is quite a complex connection, and this would be incredibly difficult to analyze and design by hand. If you go to the project tab, first and foremost, you can set up some additional information here, and here you've got some of your project items, which includes just your name, description, the analysis type, buckling, and report notes, and you can add project notes as well. So if you hit save, you'll see that this value does not update, and that's because that this is saved as part of the Checkbot file. This is not a separate standalone connection file, it's part of the Checkbot file. So don't worry, if you hit save and nothing changes here, it doesn't mean that it's not been saved, but rather that it is part of a Checkbot file and that this information is drawn from the Checkbot file. Versus creating a connection from scratch by opening up connection on its own, then saving it, this information up here will most definitely update. So, all right, looking at our connection, we can see first and foremost that the column is short. All right, so we actually want the column to extend just above these flanges. And the reason for that is that this is how we would model in something like robot or sumo. So we'd model, apologies, we'd model towards a common point, and that geometry is taken as is from robot. Now you can go into robot and extend the column and restart this whole process. It will work, not perfectly, but it will work. Or you can make use of a special operation. So the operations are the processes that we will use to add our different plates and so forth. All right, so I'll click on operation and I'll use cut first and foremost. So the member will be column 4, and it will be cut by beam 15. So I'll say beam 15 and select the top flange option. I'll change the direction from parallel to perpendicular. I'll click extend member. And then I'll also just put in offset of -20. Okay, that offset value can be different. If the offset is 0, it extends to the bottom of the top flange. Okay. That's all good and well because we want our end plates to be modeled properly. So there we go. Cut is sorted. Now I'm going to click on operation, select end plate, and this is going to be for beam 11, and it's connected to column 4. All right. So usually it will also require that you select the bolt grade and size as well, and you can always go and change it if need be. I'm going to add another end plate as well. This time it's going to be from member 12, connected to column 4. And you can see that our connection is now starting to take shape. All right, we will edit some of these values. I can maybe even just increase the size of this weld so long. But we will change this. All right, so please don't worry too much about that now. We'll extend this base plate a little bit. Okay. Then we want to actually connect this beam with a fin plate to the column's web. So again, operation, there's fin plate over there. It's going to be for beam 15 and it's connected to column 4, and we can say that it's web 1. So remember, part is web 1, and there we go. All right. So the critical stuff has been changed already, and you can see that that was fast actually. Very easy. Once you know what you're doing and the operations that you're looking for, it really is quite easy. So all right, I'm going to go to project and just hit save to make sure that this information isn't lost. All right, now I actually want to add some gussets here. Now this process can take a little bit of time. All right, so bear with me as I run through the process of actually setting up these braces. Alrighty, so looking at our braces, what we're going to do is we are going to add a gusset operation. So you can actually make use of two. Use gusset truss members or connecting plate beam to beam or column. So I'm going to use gusset. And now this is member B22. So this is the relevant member. New plate is fine, related to beam 12 because I'm on this side. And then also related to the column. But you can see there's a little cross there. Just change it to member and then select column 4. Okay, so firstly, it just looks a bit orkies. So we're going to change this to 5 mil and 5 mil. I'm going to change the thickness here to 10 mil because the angle is also just 10 mil thick. That's 100 by 100 by 10 angle. And now I'm going to change the shape to chamfered. And I'm going to make this 250 by 250. All right. I might actually have to add a bit to that. So let's make it 300 and 300. You can change these dimensions. So that's your D1 and D2. So let's make them 25 and 25. We can increase the gap shortly. Center, we want to check front. Right. So that moves this gusset plate a bit back. Just look what happens if we say rear. Right, rear is a bit weird. That won't work. You can do center and then you'll have to notch the member. Not that that's anything, I've never seen something done like that, but you can experiment if you want to. So alignment needs to be front. You can play around with this gap. You can see what that gap is there. Right, we actually may want to add a bit to that gap. So let's see, 50 mil, and then we can always add, let's do 325, 325 for our gusset. Does feel like we actually waste quite a bit of metal here, so we can then work back, just say, okay, what are we happy with, and then maybe change this to, let's say, 250 and 250. Okay, and you can see that actually cuts back a bit on the amount of weld we have available, so we'll check that. The analysis will help us with that. Then the plate, I want the weld to be double-sided. I'm happy with 5 mil fillets on each side, so that's for the plate here. And then here, I actually want to just have the fillet weld on the front side. And you can see that it's over there as well. Now, this is just because of how the program works, that it looks like that. But in all intents and purposes, we can see that at a normal angle, this weld will be against this plate over here, but it won't affect the analysis. That's just how the program works. Okay, so I'm going to go project and just save again. And we're going to do exactly the same on the other side. So again, a gusset, the member is B25, related to beam 11, and then also related to column 4. Material is 275. Thickness is 10 mil. And what did we say was for the previous ones? 250, 250, because we're going to do exactly the same on either side. 250, 250. The shape is chamfered. We're going for 25, 25. The gap here is 30. And then what have I done here? Just see quickly, related to beam 22, 12, and column 4. I think I might have just made a mistake there. Okay, so just back to gusset 1. I want this to be front. In this case, actually, this should be rear. And the gap is 30, 30. And that looks pretty much the same for me. I need to just make sure of the plate welds. So I want these to be 5 mil on both sides for the plate. And then for the member, it should be 5 mil and just on the one side. So this could probably be fillet rear side. No, fillet front side. Okay. And that looks about right. You see that they're nice and symmetrical. That all looks good. And we can see that everything here is basically done. Okay, now I can just look at the more finicky things, so we can see our end plates need a bit of help. So I'm going to go to my first end plate, and the top I'm going to probably extend by 10 mil, and that seems to do the trick. The same with the bottom. Same with the bottom also, just 10 mil. And then this side as well, 10 mil and 10 mil. Okay, so these bolts might not be enough, so we might actually have to change up some of our information here. But we see there, we've got a bit of a problem. It says EP1 end plate passes through the gusset plate. So where's EP1? Okay, so this is EP1. And we can see that there's a problem in the corner here. So there's a cool way to solve this. So I'm going to select this gusset, and I'm going to click on the editor button, and I'm going to add a chamfer to that corner over there. So chamfer, the value should be 25, and then the corner, let's see, it's corner 5, I think. Okay, I'm going to apply that, click OK, and we can see that that actually resolved that error. Do the same on this side. Go to editor, chamfer 25, and it's going to be on corner number 5. Apply and OK, and our problems have been solved thus far. It's never as easy as this, right, in general, but there we go. We've actually got a working connection. I'm going to hit save, and then what we should do is start the calculation process, which can be quite long actually, just because we've got so many load effects for the program to run through, and then we'll see actually what's what and what we need to change. Okay, so I'm going to click on calculate, and then I'm going to skip over this section for you. Alrighty, so what I did is I ended up unticking most of these load effects just to simplify or actually just to shorten the duration of the analysis. And we can see that it all runs normally, but our plates are exceeding the design check considerably. So that's 5% plastic limit strainer, we have 152, and our bolts and welds are basically, they exceeded by essentially double what they can handle. So what we then do is we're going to go to check, and we're going to have a look at our plates, and we see there that's beam 15, the web, you can see the web there, column 4, the web, and then if we scroll down, we see there's actually FP1, which is the fin plate. So we're going to start with changing those. We're going to go back to design. I am going to delete this fin plate and actually just replace it with a cleat. So that is for our beam 15, and it is connected to our column 4. So for some bizarre reason, I don't know why, but let's see why exactly this is a problem. Why that updates, I don't know, but this should be beam 25 is related to beam 11 and then column 4, and it is then on the rear, and then that should all be fine still actually. So that's just something to look out for. I don't know why that changes. I'm just going to go and save, and then we're going to have a quick look at this cleat, and I'm happy with that profile because it matches that of my braces. Happy with the bolts so far. Actually, I will actually change those up a little bit. But if we see, there's quite a lot we can change here. Right. So if we want to double up on this cleat, let's just start actually by changing the values that we want changed. So if we say the cleat length, yeah, there we go. Now we see it all updating nicely. Quite happy with that. Our gap is that little gap there. As you can see, if we increase that, that gap increases. All right. And then we're going to just change some of this information here. So we can have the same on both legs. So you can see if I change that, then I can actually change the information here as well. But I want the same on both legs. And then of course, the size of the cleat depends, of course, on the profile I've selected. So the type of angle, of course, because it's cut from an angle. Right, so I'm going to change these a bit. So I just want, let's just do -25. Change that to -50. Okay, so negative is clearly the wrong answer. So we can do that as 15. And we actually might have a problem with edge distances here. But let's see. Let's just see how that goes. All right, so transverse, let's see. Okay, so there's the transverse. So we can go 30, or let's do 50. And then we can do a semicolon and -50. I'll probably want to add a bit more. So I'm going to do 80. Okay, 80 seems good. And then let's do at 40 and -40 as well. See what that looks like. Okay, change that a bit. Let's do 30. Okay, that looks okay. That looks okay. So I want to see if I can double up on this particular cleat. So just have a cleat on the either side as well. And that would just be both. As simple as that. So location, got front and rear, and then both. And I think what can be a bit tricky here is that you're not always sure. It's not always, especially in this type of scenario. Maybe it's clear to you as well, but I wouldn't have initially thought to look at location in terms of doubling up on the number of cleats. So if you're struggling to find a particular feature, you don't know if it's possible, actually just experiment a little bit with your different parameters. All right, so I'm quite happy with that. Let's see how that turns out. I'm going to save this and then run the analysis again, and then spare you just the time it takes to run through the analysis. So luckily it's only one, which is quite quick, but let's see. I wonder if it's actually going to go through this quicker. I'm not sure, but you can see here it is all running, and then I'll be back as soon as this is done. All right, and back with our analysis, and we can see that there is a considerable improvement. So analysis 100%. Our plates are now at 4.1% plastic limit strain. Now that's within limits, but I've heard some reservations with regards to that, and that some engineers would even say that 2% is even pushing it. Right, so that is up to you as a designer. And the only thing that fails is our welds, and with 100.6. So what we want to go do is just go to our check, and we want to go to welds, and I want to see which weld is it that failed. So it's gusset 2. All right, so it's gusset 2. So we want to increase the size of our welds a little bit. So I'm going to go back to design. I'm going to go to my gussets. Okay, so we're in the design space, and I want to increase their size a bit. So 6, and then 6, and 6 as well. All right, and the rest of this I'm happy with. And I'm going to go to project, hit save. And we can actually see now it's updated to connection 02. That's probably based on the fact that we've given it a name. I'm not sure. I actually think that previously the program was giving me a little bit of grief, and then I had to restart it. But okay, let's go for our calculation again. And again, I'm going to start it off, and then I'll be back as soon as it's finished. And we're back, and we can actually see with those minor changes, all the checks have passed. Again, I would look at that 4.1% and maybe even want to get it lower than that. But for this exercise, actually everything has passed its different checks, which is epic, which means that this connection, for all intents and purposes at this stage, again, I'm not making a design call here. There's maybe some things that you want to check, but for what we are looking to achieve, we've actually passed all of our checks. So if we go to check and maybe we look at equivalent stress. Right, so we're just waiting for that to update. We can see that the stress values are incredibly high in this location, and that's probably why we are sitting at a plastic strain of 4.1%, because of course the Eurocode allows you to exceed the yield stress of the material as the 5% plastic limit strain is then the design criteria for that. Okay, so we can actually exceed the yield stress of the material, and then we start going into our plastic strain. Okay, so what you might end up doing is changing the material, right? Changing it from S275 to S355 or something like that, and just, yeah, that will actually just, I think that should have quite an effect on the plastic limit strain. So then we can click on mesh, and we can deform it as well. So there's our mesh, and if we click on deformed, let's just see what that looks like, and there we can see our deformed shape. All right, so I'm going to change this to a scale of 1. All right, there we see 1, and there is actually a bit something going on here. All right, okay, so that is that. I'm going to show you guys quickly. If you go to report, just if we generate a report, so here you can tick everything you want, right? You can add some detail here. We click on generate, and it will generate a report, and you can export this connection as an IFC as well as a DXF for the plates and so forth, which is quite cool. But here's our connection, or rather our report, which is really cool. It's super detailed, which is really, really epic. I love how detailed this report is. Really cool way of getting to know the Eurocodes as well. And that is it. Oh, look at that. Okay, here we've actually got all of our gusset information as well. Just flippin' cool. So there's all of your drawings as well. And that is it for our part 2 connection. So in part 3, we'll be looking, of course, at our part 3 connection and running through that as well. So thank you so much for tuning in. I really hope that you have enjoyed this clip. If you have any questions, please pop them in the chat. And if you want any further information, you're also welcome to email me directly. So thank you for tuning in, and hope that you have an awesome day further. And stay tuned for part 3.